Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're going to continue with adding rational, well actually we're going to start adding rational expressions. And we already learned how to find an LCD. And once we find an LCD, we have to convert the fractions, which we learned how to do, into equivalent rational expressions. And then we add them. So today we're going to learn how to add them once we already have the LCD. Okay? So today we're just going to learn the skill of how to add the rational expressions once we have the least common denominator. So this is the easy part. We already learned how to find the LCD. We learned how to convert the expressions into equivalent expressions with LCD. Now today we're going to learn how to add these rational expressions once we have the LCD. And it's quite simple. In order to add and subtract rational expressions with common denominators, simply add or subtract the numerators, literally, and keep the same common denominator. Simplify the final rational expression to lowest terms. We know how to simplify rational expressions already. So we're starting to build on the skills that we have already learned. Okay? So it's pretty simple. It's just like adding regular fractions. If I told you 1/7 plus 3/7, this would equal 1/7 plus 3/7 equals 4/7. And that's it. You're done. Okay? It's that simple. So, let's do it. I have 5, just in case anyone has to write it still, 5 over x plus 1 plus 3 over x plus 1. We have the common denominator of x plus 1, so I literally add the numerators and keep the same denominator. 5 plus 3 is 8 over x plus 1. I'm done. That's it. Done. Number 2. I've got now x squared over x plus 7 plus 7x over x plus 7. So x squared plus 7x is x squared plus 7x over x plus 7. Now, I always have to simplify my rational expressions. But Mr. Moore, you didn't simplify the first one. No, because I couldn't. I couldn't simplify 8 and x plus 1. However, I can simplify this one because I can factor out an x from my numerator, leave me with an x plus 7 divided by an x plus 7. And now remember what we said. Since I have an x plus 7 in the numerator and I have another identical binomial x plus 7 in the denominator, I can get rid of these identical binomials and I'm left with x in the numerator. I'm done. Now, the temptation. This is a big temptation. And I know it is. That's why I want to go over it. A lot of people will say, oh, but can't I just go, oh, let me get rid of this guy and this guy and then this guy and this guy? I'm still going to be left with x, Mr. Morrow. Yeah, you got lucky though, and that's completely wrong. Okay? You cannot do this. No. Do not do that. It's mathematically illegal. You cannot do that. You cannot simplify by taking individual pieces of polynomials. So you can only simplify by canceling out monomials with monomials, or binomials with binomials, or trinomials with trinomials, perfect polynomials with perfect polynomials. You cannot take away individual polynomials or individual pieces of polynomials. You just can't do it, unfortunately. Number 3. I got 2x squared plus x over x squared minus 4 plus x minus x squared over x squared minus 4. So 2x squared minus x squared is x squared. X plus x is plus x over x squared minus 4. Yes, sir. It is 2x, and maybe I should learn how to add. Thank you, sir. So 2x squared minus x squared is x squared. X plus x is usually 2x. Thank you very much, sir. And then I have over x squared minus 4. Thank you once again for that. So when I factor out an x, I've got x times x plus 2 over x squared minus 4. I got to factor it. So that's x plus 2x minus 2. That's a difference of squares. And why did I say x minus 2, but I put x minus 4? Come on, Moro. Pay attention. Pay attention. So now I have an x plus 2 and an x plus 2 on the top and the bottom. Those are perfect binomials. They cancel. The temptation is to say, Moro, I got an x and an x. No, you do not. You've got an x and you got an x minus 2. You got a monomial and a binomial. So this is an x over x minus 2. Yes, sir, my brother. Question. Thank you. What's up, brother? Come again, my brother? Why would it be x times x minus 1, sir? I factor out an x from here. So when I factor out an x from here, my brother, I take away an x from here and x from here. When I factor out an x, x squared divided by x is x, and 2x divided by x is a 2, sir. No, sir. 2x squared minus an x is an x squared, sir. And then x plus x is 2x, sir. Thank you for caring. Thank you for your honesty, my brother. Thank you so much. Thank you, thank you, thank you. Okay, next. This is a very, very big problem for a lot of my students. So please pay particular attention to this. When you are subtracting, this negative here, gentlemen, must be distributed. So what I like to train my students to do takes an extra step, but it's worth doing in my opinion. This is a squared plus 2a minus a squared minus 12. I distribute to here and to here. All of it is over. But wait. Look at what I did here first. I didn't pay attention. These two guys are not the same, are they? No. What I said before is valid. This negative always does distribute, but you got to pay attention to make sure they're the same. So first I got to factor out a negative from here, making this a minus 4. And then where does this negative go? Up here. So what does this negative become? A positive. Now I can rock and roll. If that was a positive to begin with, it would have become a negative. Then I would have had to distribute. Does that make sense? So a squared plus a squared is 2a squared plus 2a plus 12 over a minus 4. Now, unfortunately, gentlemen, I do have to factor. So I factor out a 2 from the numerator. So I got a 2 times a squared plus a plus 6 over a minus 4. And then I cannot factor this. What times what is 6, but when added together is 1? Nothing. If that 6 was a negative, then it could have worked out, but it's not. So ding dong, the witch is gone. That's it. I'm done. That is done. Now here I can actually talk to you about distributing that negative because I have a denominator of x plus 1 on both. So now I would rewrite this as 9x plus 1, distribute that negative, minus 6x plus 2. I cannot tell you how important that is, gentlemen. Please, please, please focus on that. That is, bless you, the number one reason that most people get these wrong, especially for the subtraction. It's not that you don't know how to do it, it's that you forget to distribute that negative. And forgetting that negative really messes you up, y'all. So 9x minus 6x is 3x plus 3 over x plus 1. I can factor out a 3 from the numerator, giving me an x plus 1 over x plus 1. The x plus 1's cancel, and I have 3 as my answer. Does that make sense, gentlemen? Any questions on 1 through 5 before I continue? Yes, sir, my brother. Thank you. Well, the negative can't go to the top and the bottom. It can only go one place or the other. And let's think about it logically. If I were to go ahead and put this negative and distribute it to the bottom, am I keeping the denominators the same then in that case? So it's a brilliant question. Thank you so much. You always want to keep the denominators the same here, my brother. So this negative is definitely going to be distributed to the numerator. Once you have the common denominator, you don't want to mess with the denominators. The denominators you want to keep the same. So any manipulations that have to occur are going to always occur to the numerator. Because the denominator, you want to keep them the same. Does that help? Does that answer your question, my brother? You sure?
It was like where, like let's say the section for number 5, if the x plus 1 was negative x.
Oh, okay, let's do it. Let's do it like that. Let me show you. Thank you. What he's saying is this. Let's say I have an x plus 3, or let's say this was a plus, okay? And then I have whatever, x minus 2, and then I have whatever, x plus 5 over 2 minus x. This is what he's saying. In this particular case, I don't have a common denominator yet. But I'm going to factor out a negative 1 here, giving me an x minus 2. This negative must be transferred up here. When I transfer this negative up here, what does this positive become? A negative. Where does this negative distribute to? The numerator. So this now rewrites as x plus 3 minus x minus 5 over x minus 2. Which then equals x minus x is 0, my brother. 3 minus 5 is negative 2 over x minus 2. What's the temptation?
Cancel out singular parts of the binomial.
The temptation is to cancel out that negative 2. Please do not be tempted by that. You cannot simplify or cancel out individual pieces of polynomials. Good job. Does that make sense, brother? Brilliant question. Thank you. I bet you money you helped a lot of people with that question. Thank you, son. Any other questions on 1 through 5 before I continue? I got plenty of time, though. I want to make sure this works. Because our next step, guys, is combining it all. Finding the LCD, convert to equivalent, and then add. But you see, that's why I wanted to show you. How do we find the LCD and find the equivalent fractions? How do we add them together once they have LCDs, and then do it all together? May I continue? Thank you, brothers. Okay, let's rock and roll. How do we do this one? What do we do here? Yeah, this is just negative 7, right? So what's 10 minus 7? 3 plus 3y over 6y. What can I factor out of here, my brothers, out of the numerator? A 3. What will that leave me with, my brothers? Y plus 1. You can put 1 plus y, no doubt. But you know me, I like to put things in standard form. And it's not me, it's math. Over 6y. Can I reduce this at all, gentlemen? Yeah, I could take a 3 out of a 3. It goes in 1 time. 3 goes into 6 2 times. So I've got y plus 1 over 2y. What is the temptation that we will not fall prey to? Yeah, temptation is to cancel out the y. We can't. The 2y is a monomial. The y plus 1 is a binomial. I cannot take away individual pieces from a polynomial. Okay, this is a good one. What do I have to do here to the denominator before I can start doing anything here? Yeah, I got to factor out a negative, which gives me a y squared, a w squared minus 16. What do I do with that negative, though? Bring it up, which becomes a positive, right? So now I've got 2w plus 6 over w plus 4 times w minus 4, because that's the difference of squares. And then I take out a 2, so I've got 2 times w plus 3 over w plus 4 times w minus 4. Now, a lot of my students sometimes say, Moro, that's nice and all, and that's, I appreciate it, that's real nice, but you factored for nothing, Moro. Why are you making us do this? Why do you hate us? Guys, I don't hate you. I love you very much. But the problem is this. If I don't teach you to factor it all the way, what happens? When you do have a situation where you have to cancel it out, I'm going to hurt you in that case. Then you're not going to get the right answer. So my rule of thumb is factor it all the way. You factor the numerator all the way. Hey, man, if you have something you cancel out, woohoo, great job. If you have something that you cannot factor, woo, great job. Either way, it's factored, it's beautiful, and it's ready to go. In this particular case, there was nothing that we could cancel. Okay, great, who cares? So what? Not a big deal. But you'll always factor that numerator. Always, y'all, no matter what. Does that make sense? Okay. What do I have to do to this bad boy right here in order to have a common denominator, y'all? You darn right, you got to do that. Well done, my brothers. So I factor out a negative giving me an x minus 5. What do I do with that negative, y'all? That's right. So that becomes a negative now. So this is 3x minus 1 over x minus 5. Can I factor the numerator in any way, shape, or form here, y'all? No, I can't. Very good, son. Thank you for paying attention. Done. It's done and done. Okay, I got another situation here. What do I have to do here to get that denominator? Very good, my man. That's my boy. Good job, son. Well done. So I'm going to factor out a negative here, just like my boy told me. And I got 6y minus 6. I'm going to bring that negative up. I am just verbatim repeating what my boy just told me. This becomes a negative. So now this is 2y. Please remember to distribute. Guys, I've been doing this for almost 20 years, and I still use arrows to remind myself. I'm not showing off. I'm actually showing you how I have to do things. Okay? I'm showing you how simple I make my life. I'm not that fancy. Some of you are going to say, I don't need to show myself arrows. Okay, don't do it. But think about it. I'm the teacher. I've been doing this for a long time. And if I do it, do you think it would behoove you to do it? I think it would, but that's up to you. It's your choice. You got to be a man that has to do what you got to do. So this is minus 9 minus 4y over 6y minus 6. Let's clean it up and factor. This is now negative 2y minus 9 over 6 times y minus 1. This comes out to be negative 2y plus 9 over 6 times y minus 1. Yes, sir. What? Did I mess up? Did I mess up? Did I? No, I did not. 2y minus 4y is negative 2y. 2y minus 4y is negative 2y. No, dude. Thank you, sir. At least you're caring and you're paying attention. Thank you. Thank you very much. You're caring, bro. That's all I can ask for. Now, again, you may get a little upset with me, though, and you're going to say, there he goes again. He factored for nothing. No, I didn't factor for nothing, guys. I factored for something. I'm trying to see if I can cancel out. If I can cancel out, then woohoo! All right, great. If I can't, woohoo! Okay, great. Doesn't matter. I'm factored. It's purity. It's beautiful. It's awesome. Does that make sense? As you can see, we got plenty of time here, guys. Thank you, sir. Talk to me. I don't know what you mean. The negative in the parentheses. There is no negative in the parentheses. No, it's not a little line, Papa. There's a negative. This is called a negative, not a little line. Because I factored a negative out, Papa. There's a negative here and a negative here, so I factored a negative one out. When I factor a negative one out, my brother, I factored a negative one out. So I factored a negative one out, and I'm left with a 2y plus 9, my brother. Why did I do it? Because I had just finished saying, thank you for asking, for caring. I had just said you always have to factor the numerator to completion. So since this negative 2y and that negative 9, what did they have in common? They had a negative 1 in common. So what did I have to factor out? I had to factor out a negative 1. So I took a negative 1 out. Now, if that confuses you, you could do this if it makes more sense to you, and I'm totally down with it. I factor out a negative 1. If that is clearer for you, my brother. Like totally, I understand. Completely. If that makes more sense, if that's visually more appealing to you, that's completely accurate as well, sir. Thank you for your honesty, sir. Does that make sense, gentlemen? Awesome. Okay, now, let's do this. Okay, cubic method. I got 3x, because we got the denominators already, right? That are the same. So I've got, oh, actually, wait, what's wrong with me? Come on, Moro, boo. Boo. Come on, Moro, pay attention. You got to distribute first. What's wrong with me? Practice what you preach. Excuse me for 1 second. Okay, thank you. Welcome back. Okay, so we're going to distribute that. So we got 3x squared plus 8x minus 1 minus 2x squared minus 2x plus 9. So let's clean that up. 3x squared minus 2x squared is x squared plus 6x plus 8 over x squared minus 3x minus 28. Now let's factor. So what times what is 8, but when added together is 6? Positive 4, positive 2. Excellent, gentlemen. And what times what is negative 28, but when added together is negative 3? Negative 7, positive 4. Guess what? X plus 4 is a perfect binomial with x plus 4. So my answer is x plus 2 and over x minus 7. And you have just added your rational expressions. Does that make sense, guys? Yes, sir, my brother. That's a beautiful question, son. I'm quite impressed with that. The question was, what if there's a negative here, Mr. Moore? What if you start with negative x, whatever, squared plus 3 over x minus 5, let's say, plus 3x squared plus 2 over x minus 5. Okay. This negative, son, belongs to this x squared and this x squared alone. So, moral, why is it that if I had a negative here, I distribute? Because think about it. This is saying I'm subtracting this whole quantity. So when it's in the middle, I have to distribute. When it's at the beginning, that just means that this first term is negative. Now, let's look at it like this, though. If I had said this to you, my brother, negative x plus 4 plus whatever, x minus 5, whatever, x over x plus 2, x plus 2. Now I have to distribute that negative. You feel me? But in the middle, when it's in the middle, I have to distribute it. If it's in the beginning and there's parentheses, I distribute it to the first one. But if I just start out with negative, for example, 3x squared plus 2, that negative belongs to this first term and this first term alone. Does that answer your question? You sure? Does that make sense to all of y'all? Sir, and then sir. In the numerator or denominator, my brother? So you're asking me, it says negative x squared plus 25, okay, and then? Okay, so let's just make a whole problem out of it. Let's just do, let's say, over x plus 2, and then let's just go plus, oh, no, not yet. Because you're adding this to something else. Right? So like, let's say whatever I had, I don't know, 3x squared, whatever, plus 20 over x plus 2. The question was, can I factor out a negative from here and then factor? No. Because you first have to add the numerators before you can simplify. Do you see what I'm saying? Now, scratch this for a second. Let's say that at the end, after you've added everything, your sum, you're left with, this is after everything has been done, Your answer is negative x squared plus 25 over, let's say, x plus 5. Ah, now I can factor out a negative 1 from the top, giving me x squared minus 25 over x plus 5. Now I can factor the top into x plus 5, x minus 5 over x plus 5. Now I can cancel out the x plus 5s, and now my answer would be negative x minus 5. But that is only if and only if that's how my answer came out after I had already added the numerators, after I had already simplified the numerator. But if I start like this, I got to go ahead and add it first, my brother. I cannot factor the numerators before I add. Does that make sense? Does that answer your question clearly? Thank you. I still got time, guys. Sure, my brother. That's why I'm this is your day. You tell me what you need, my man.
When you get to the point, when you're like 2y minus 9, and you haven't factored out a 3, you haven't simplified yet, like the 6y minus 6.
Yes, sir.
Could you cross out the minus 6 and the minus 9 and simplify?
Okay. This was the question. We're going to do it one more time. Thank you for your honesty, sir. Okay. First of all, I'm going to factor out a negative here. So this is 6y minus 6. You're going to bring that negative up, and I'm going to distribute that. So I've got 2y minus 9 minus 4y over 6y minus 6. The question here was, can I simplify this negative 9 and this negative 6? I have said this at least 10 times today, probably 25 times throughout rational expressions, but I'll say it again because at least you had the guts to ask, and I appreciate that, and I thank you. You cannot simplify or cancel out individual pieces of polynomials. So the answer is no, sir. You cannot. It is mathematically illegal. You cannot do it. It's impossible. Because this is a polynomial here. There is no negative 9 there, really. What you have here is 2y minus 4y, which is negative 2y minus 9, which is negative 2y plus 9. That's a binomial, my brother. Over 6 times y minus 1. This is negative 2y minus 9. That's a binomial. Over 6y minus 6. That's a binomial. I cannot individually start taking pieces away from that. I either have a perfect binomial that I can take away, or I cannot. Now, I can take away monomials, but I don't have any monomials here. Moro, what are you talking about, a monomial? Guys, I hope you know what monomials are. If I had, for example, 3x times x plus 2 over 6x squared x minus 5. Oh, this is a whole different ball of wax. That's a monomial. That's a monomial. We can cancel out monomials. A 3 goes into 3 one time. A 3 goes into 6 two times. So I got 1/2. I have 1x in the numerator, 2x in the denominator. Get rid of 1x here, get rid of 1x here. I got 1x here. But now, can I get rid of this x and this x? No. So this is an x plus 2 over x minus 5. Done. Does that help you, son? Are you sure? Do you want to maybe write down some notes on that so you remember that? Thank you, sir. I appreciate your honesty. Anything else, boys? Thank you so much for your honesty. I got plenty of time. This is my job, guys. This is what I love. Talk to me. Awesome. Come again, sir? Yeah, come on, man. Talk to me. What's up, brother? Okay. Thank you very much. Hope you learned a lot and have a great day.